Now, this part we have completed. The internal energy can be changed by two methods. One is heating the gas and other is by doing the work. So, work done can be positive or negative. So, we have seen last time when the gas pushes the piston outward, work is done by the gas on the piston or work is done by the system. In that case, during the volume expansion, some energy of the gas is used during the displacement of the piston, therefore its internal energy decreases and work done is positive. So work done is positive during the volume expansion and volume compression, the work done is negative. आपण ते केमिस्ट्री मधल्या इक्वेशन वरून पण प्रूव्ह केलं होतं ते. W work done is equal to 2.303 nRT into log of V2 upon V1 to the base 10. So V2 is a final volume, V1 is a initial volume. It is called as a volume expansion ratio. So that V2 is greater than V1, volume expansion, work done is positive. V2 less than V1, then logarithmic term will have minus sign and work done is negative. The equation वरून पण आपण ते कन्फर्म केलेलं आहे. So work done may be positive, may be negative. Now, when the gas pushes the piston, volume increases. When the piston pushes the gas, then there is a volume compression. So in both the cases, there is a change in volume. So during the change in volume of the system, there is some work done in case of gaseous system. So we have to find that expression. Expression for work done during the change in volume of the system. Expression for work done during change in volume of a system. Like this. So, as usual, we will consider the situation like this. Consider a gaseous system enclosed in a cylinder with a movable, massless and frictionless piston like this. So, this is a cylinder fitted with a piston this is the initial portion of the piston and now it is pushed up here. So this is the initial position of piston, means we are considering the volume expansion. Final position of the piston. This displacement is a very small displacement dx. This is the gas. So this is the piston. Like this. So this one part is the volume expansion. This A is the area of the piston. A is also the area of the cross-sectional area of the cylinder. So consider a gas enclosed. It is a closed system. A gas enclosed in a cylinder by movable massless, frictionless, piston has shown in the figure. So gas is a system and cylinder plus piston is the environment. So the piston is initially in this position, so motion of the piston is in this direction. Motion of the piston is in the outward direction. Outward direction means its position changes so that its volume increases like this. A is the area of cross section. Like this. So A is equal to area of the piston. It is also equal to area of cross section of the cylinder. Area of cross section of the cylinder. When gas pushes the piston outward, that is, when gas expand at constant pressure P, then the force exerted by gas on piston F is equal to P or pressure F or area of cross section. We know that pressure is defined as force per unit area. Therefore, force is equal to pressure multiplied by area, like this. Now, this force is exerted in this direction because motion of the piston is in this direction, and therefore the piston moves through distance dx. So, during this displacement, some work is done by the gas due to force F. The piston is displaced through infinitesimally small distance dx. Therefore, small amount of work dW is done by gas, that is system, on piston. dW is equal to force multiplied by displacement is equal to P into A into dx. So this is the question 1, where A into dx is equal to dV is equal to small increase in volume. volume increases by dV, small increase in volume. So dW is equal to pressure multiplied by dV. This is equation 2. So at constant pressure, if the volume of the gas increases by dV, then dW is given by P into dV, like this one. Now this is for very small change in the volume. Now if there is a considerably large change in the volume, then that work done is denoted by W and it is given by this relation, by integration method. So we can use the integral calculus. Let W is equal to total amount of work done. आपल्याला याचाच फॉर्म्युला डिराइव करायला सांगितलेला आहे. Total amount of work done when there is a finite increase in volume from initial volume Vi, V1 पण आपण त्याला म्हणू शकतो initial volume Vi to final volume Vf, final volume Vf. Then W is obtained by integrating this equation, and therefore W is given by integration of dW from lower limit Vi initial Vf final solution. So this is equal to integration of PdV Vi Vf. Pressure is constant, it is taken outside the integration of dV Vi Vf. So this is equal to P into the dV is the integration V, lower limit is Vi, upper limit is Vf, and therefore W is equal to P multiplied by, now we know the rule to calculate the finite integration. So substitute variable is equal to upper limit, substitute variable is equal to lower limit, and subtract. So this is the expression for the work done during the volume change. Now if Vf is less than Vi, then work done will be negative. So work done is positive for volume expansion. W is positive during volume expansion. Volume expansion. Vf is greater than Vi. Work done is negative during volume compression. Volume compression. Final volume less than initial volume Vi. So these two results are important. So work done during the change in volume may be positive or may be negative. This is the expression for the now we know the change in internal energy, it is also positive or negative. If the heat is added, then this internal energy increases. Heat added, then it is positive sign. If internal energy increases, plus sign, like this. So here we are using some sign conventions. Sign convention. So those sign conventions are like this. So now we add the heat to the system or remove the from the system. The internal energy may increase or decrease depending upon the heat supplied or removed, etc. Work done may be positive, negative, and therefore we have to use sign convention when we write down the thermodynamical equation for the system. So those sign conventions are like this. So first we will see the sign convention for the heat. So heat energy is denoted by Q. So Q is positive when heat is added to the system, and Q is negative when heat is removed from system, from system. Second, second term is internal energy. Internal energy delta U. Change in internal energy. Change in internal energy delta U. Delta U is positive delta U is positive when internal energy of the system internal energy of the system increases and delta U is negative when internal energy of the system decreases. Third, work done W. आता आपण बघितलं पॉझिटिव्ह निगेटिव्ह वर्क डन केव्हा असतं ते. W is positive when work is done by the system, that is gas, volumic function. During volume expansion, work done W is negative when work is done on the system, that is gas, during volume compression. So this is a very important part, not given in our notes. So please add it. add 2 nodes. While solving the numerical problem, also for some theory question, MCQ question, we will require this sign convention. So this first term is Q. Q is considered positive when heat is added to the system. Q is negative when the heat is given out by the system or when it is removed from the system. So delta U is change in internal energy is positive when internal energy of the system increases. Delta U is negative when decreases. Work done is positive during volume expansion. So during volume expansion, the gas pushes the piston outward and therefore volume increases like this. Work done is negative when the work is done on the system. So when the piston pushes the gas during the volume compression. So these are the cases. Now remember these sign conventions. Now we know the zeroth law. It is related with thermal equilibrium of the system. Now we have to consider the first law, very important law. Actually, it is a consequence of the law of conservation of energy. Energy cannot be created, not be destroyed, but it can be converted from one form to another form like this. So let us derive this equation of the first law of thermodynamics, and for that purpose we are considering the two processes like this. Now we know about the internal energy. Internal energy can be changed either by heating or by doing the work. So that second part, by doing the work and heating, both part we are going to consider here again. So suppose Q is the heat added to the system and the system does not do any work, means there is no change in volume during the process, then internal energy will increase. So case number 1. Case number 1. When Q heat is added to a system and no work is done, that is W is equal to or dW is equal to 0, then the internal energy of the system increases by delta U is equal to Q. This is equation 1. All the heat energy supplied is used to increase the internal energy. Second case. Now here some work is done. When the system does some work but no heat is added, that is Q is equal to 0. when the system does some work for volume expansion. So we know the result. For volume expansion, the gas pushes the piston, so energy of the gas is used, therefore internal energy will decrease. So when the system does some work, in this case the work done is during the volume expansion, the work done is positive, but total internal energy decreases. So when the system does some work for volume expansion but no heat is added, then energy of the gas, energy of the system is used for volume change. Therefore, the system loses energy. Therefore, internal energy of the system decreases. Therefore, delta U is equal to decreases, therefore minus sign. जेवढं वर्क केलं असेल तेवढी एनर्जी सिस्टीममधून काढली जाते. सो दिस सिस्टीम internal energy of the system decreases, therefore minus sign. So this is equation second. So this is the change in internal energy by heating and by doing the work. Here we are adding the heat, means this is the process of heating. Here no heat is added, but there is a work done. So this internal energy changes by heating, internal energy changes by doing the work. So in general, this energy, the change in internal energy is due to the both parts. So the result, the conclusion is like this. Since internal energy of the system can be changed, by first heating it, equation 1. Second, by doing work, equation 2. दोघी सिस्टम आपण ऍड केलेले आहेत. Therefore, the total change in internal energy due to both processes, work done as well as heat supplied, both processes, is delta U is equal to Q minus W. Delta U is equal to Q minus W. So this is equation capital E. So this is the equation of the first law of thermodynamics. This equation A gives the first law of thermodynamics. Equation capital A represents first law of thermodynamics. So from this equation A, we can use the first statement of first law of thermodynamics. The change in internal energy of the system is equal to the difference between minus sign means difference between the amount of heat added to the system or heat supplied to the system and the work done by the system on its surrounding. So in this case, W is the work done or volume expansion by the system. Gas pushes the piston out. This is the case. So statement number 1 can be given like this. Statement number 1. Statement 1 of first law of thermodynamics. Statement number 1. So this is the statement. The change in internal energy of the system the change in internal energy of the system is the difference. Equation 1 statement is that this is the difference between Q and W. Difference between heat supplied to the system and work done by the system volume expansion on the surrounding. The equation is delta U is equal to Q minus W. Now, the same equation can also be arranged here like this. Therefore, Q is equal to delta U plus W. Same equation B. This is also the equation for the first law of thermodynamics. Equation B also gives equation of first law of thermodynamics. Actually, this is the energy supplied to the system. It is the increasing internal energy of the system, and this is the remaining part of the energy lost during the volume change like this. So second statement is given from this equation number B. When the amount of heat Q is added to the system, its internal energy is increased by an amount delta U, and the remaining energy is lost in the form of work done W on the surrounding like this. So statement number 2 is like this. Statement number 2. When the amount of heat Q is added left hand side, when the amount of heat Q is added to a system, then the internal energy of the system increases by its internal energy increases by delta U, and remaining energy is lost during the work done by the system on the surrounding. Like this. So This is energy supplied. It is used into the two part by the system like this, and therefore this is nothing but law of conservation of energy. So this result is important. First law of thermodynamics. First law of thermodynamics is a consequence of law of or principle of conservation of energy like this. It gives the use of consequence of the law of conservation of energy like this. So this delta Q is the change in the energy. Qच्या ऐवजी तिथे आपण डेल्टा क्यू किंवा डी क्यू पण यूज करू शकतो. सो सेम इक्वेशन कॅन ऑल्सो बी यूज इन अनदर फॉर्म. जनरली वी यूज इक्वेशन बी, and that equation B can also be given like this. dq is equal to du plus dw. This D stands for small change. When small amount of heat is added or removed in the system, then the internal energy either increases or decreases by du, and dw is the work done either by the system or on the system like this. Now we have to see the three cases of this equation of the first law of thermodynamics using the sign convention. आपण साइन कन्व्हेन्शन बुक्समध्ये दिले नाही, पण ते बघितले आपण, तर त्याचा यूज आता आपल्याला करायचा आहे. चेंज इन इंटरनल एनर्जी पॉझिटिव्ह केव्हा असेल, निगेटिव्ह केव्हा असेल आणि झिरो केव्हा असेल. So now we have to see the three cases of change in internal energy. So change in internal energy may be positive, may be negative, or may be zero. So we will consider the three cases. Case number 1. Delta U greater than 0. That is, delta U is positive. So we know sign convention. When the internal energy increases, then delta U is taken as positive, and for that purpose the situation will be like this. Suppose this is the system, and to this system the amount of heat Q is added, say 200 joule. Out of this, some work is done during the volume change here. Say 100 joule, like this. Then, what is the result? So in this case, Q is greater than W. More heat is added than work done by the system, and therefore the result is this. Q is greater than W, therefore when Q is greater than W, then more heat is added to the system than work done on the system. By the system. Therefore, delta U is equal to Q minus W, Q minus W. Therefore, this is equal to 200 minus 100. So delta U is equal to plus 100. So plus sign indicates that energy increases. Therefore, internal energy delta U is greater than 0 is positive. Second case. Delta U is less than 0, that is delta U is negative. So in this case, Q is less than W. So the arrangement is like this. Suppose this is a system. So heat is removed. Q is equal to minus 200 joule. इथे आपण हीट सप्लाय केली होती, इथे हीट आपण काढून टाकलेली. So heat is removed, therefore minus sign, and work is done arrow work is minus 100 joule. So in this case, delta U is equal to Q minus W. So Q is minus 200 minus 100. So that is equal to minus 100 joule. So potential energy decreases. So delta U is less than 0, like this. So in this case, Q is less than W. Q is greater than W when Q is less than W, then more work is done by the system than heat added to the system. ॲक्च्युली इथे मायनस आहे नाही, कारण हीट आपण काढतो. लिहिताना आपण इथे ॲडेड लिहिलेलं आहे, पण साइन कन्व्हेन्शनप्रमाणे मायनस येईल. सो हीट रिमूव्ह फ्रॉम द सिस्टम इज दिस मच, minus 200 joule, and work done is equal to minus 100 joule, like this. So in this case, this internal energy decreases. Therefore, internal energy decreases. Therefore, minus sign. Delta U is negative, like this. Internal energy increases, plus sign. Internal energy increases by 100 joule, decreases by 100 joule, like this. And now case number 3. Case number 3. Delta U is equal to 0. So in this case, Q and W are equal. So this is the system. the heat removed Q is equal to minus 200 joule. The work done on the system W is also minus 200 joule, and therefore delta U is equal to Q minus W is equal to minus 200 minus 200, so that is equal to 0. So delta U is equal to 0. So work done by the system, and when Q is equal to W, then work done by the system is equal to heat added to the system, then no rise, no increase, or no decrease, in internal energy of the system. So that delta U becomes 0. So delta U is positive, delta U is negative, and delta U is equal to 0. So these are the three cases. आता याच्यामध्ये चेंज काय होऊ शकतो? आपण जर हीट सप्लाय केली ती सर्वच्या सर्व हीट या थर्ड केसमध्ये असं बनवू शकतो. If 200 joule energy is added to the system and all the energy is used to perform the work done during the volume expansion, then again this Q will be positive, this will be also positive. Volume expansion work done is positive, heat added positive. हे दोघे पॉझिटिव्ह येतील. तरी पण इक्वेशनमध्ये डेल्टा यू इज इक्वल टू 0 येईल. हे दोघे एरो रिव्हर्स केले तरी चालतील इथे. आपण हेच सिस्टीम कन्सिडर केली पाहिजे असं नाही ते. लक्षात. इथे पण तसंच करता येऊ शकेल. So this is about the three cases of the internal energy, like this. Now we know the meaning of thermodynamical system. So the condition, the state of any thermodynamical system can be represented by the equation, and that equation involves some terms like pressure, volume, temperature, etc. Those are called as a state variable. They represent the state of the thermodynamical system. Therefore, they are also called as a state variable, and they are the measurable quantity. So that relation between these variable pressure, volume, temperature, density, mass of the gas, number of mole, etc., is called as the equation of state. So we have to derive that. We have to use that equation of state for explaining some properties of the thermodynamical system. So in the next part we will see what is meant by thermodynamical variable, what is their use, what are their relation between them, and how they are used to explain the properties of the thermodynamical system. Okay, we will stop here.